Thank you. Can you hear me? Yes. Excellent. So I'm Norm Green. I know most of you from previous ESUGs. I'm the head of engineering at Gemtalk, and I'm going to take you through our roadmap and some things we're working on, and take questions at the end if there's time. So this is my agenda. First bit is we're now 1 year Gemtalk as of May 1st. The only thing that is left from VMware is my backpack. Everything else is now 100% Gemtalk. We've been around about a year. We've done 8 product releases. We've revised our licensing model for the low-cost options, which I'll talk about later. We've hit our financial goals, and we've had 0 turnover. So we had a very successful first year. Okay, to go right into the product, about our releases, our current last major release is 3.2.0, which was shipped in April. There's bugs in that, you shouldn't use that. You should use 3.2.2, which actually just came out about a week or 2 ago. Our next release is 3.2.3. We don't know when that'll be because we're very customer driven, and when we find enough bugs, we'll bundle up and ship it. That's kind of what we do. And our next major releases will be 3.3. That'll probably be in Q1 of next year, optimistically, January of 15. So I'll just take you through some of the new things in 3.2, and then we'll go through some 3.3 stuff a little later on. We've been doing a lot of work in Unicode lately to get Unicode compliant with the ICU open source package. That has been both rewarding and challenging because it breaks a lot of old assumptions in GemStone, but we think we've got it sorted now. But there's a lot of new Unicode support in 3.2. I don't have all the details on that, but there's more to come. Indexing, this is really Dale's talk today at 12. Dale is our indexing guru, but just some of the bullet points on that, things that he's going to probably talk about. Set valued path terms, which means indexing on a collection within a collection. There's a brand new query API, a new index creation API. There's a lot of new stuff here. Something called selector path terms. There's faster lookups for date and date times with encoding now down to the B-tree nodes. And Unicode string indexes for the first time. Anyway, come and see Dale at 12. He's going to go into the gory details of all this stuff. We've added some more features to our hot standby. Hot standby is like what you get with, you can think of Oracle clustering, where you have a main database and then other one or more databases that are in constant restore mode up to the second current. We've added SSL to the hot standby, so if you want to have your hot standby database out in the cloud somewhere, you don't have to worry about someone snooping on your data. We can now encrypt that connection. That's optional. We've also added a thread-safe GCI, which is the GemStone C interface. That's kind of in preview mode right now. There's a DLL out there and a header file and an API, but we're not calling it yet internally, but it's there and it's known to work. And we will anticipate moving to a completely thread-safe GCI somewhere down the road once we integrate that with GBS, the Gem Builder for Smalltalk, which is internally our biggest user of the GCI. Also, this is new. We now support 64-bit VisualWorks clients. So you can have a 64-bit Windows clients. You can have a 64-bit VM now on VisualWorks running on Windows and talk to GemStone. We had 64-bit support for VisualWorks previously, but just not Windows because we didn't have a 64-bit DLL that did the GCI stuff. So we've finally got that working now, and there may be a customer deploying that configuration possibly next year. Something else we've been doing is large memory page support. We've got customers now that want to run the entire database in memory. We have one customer now that has 2 terabytes of RAM on the box, and they dedicate half of that to GemStone caching. So you want to run database in memory. One way that helps do that is use the large virtual memory pages instead of 4K pages. So there's some support and setup to make that work. You also have to make some changes in the kernel. But assuming you do all that, GemStone is now set up to exploit that. And we support that both on AIX and Linux. On Solaris, it doesn't seem to make any difference whether you do it or not, so we just didn't do it. There's some more Prof Monitor enhancement. Prof Monitor is our performance profiling tool that ships with GemStone. We've got much better object creation tracking now than we used to have. The Prof Monitor still has more work to be done in future releases. It's better, but it's not where we want it yet, so we're constantly working on improving it. 3.2, we also did some more multi-threading internally, and there's been some re-architecture with the page reclaim sessions. Before 3.2, you had one or more of these reclaim processes. Each one was its own kind of gem VM, and they ran and they did the reclaim thing. In 3.2 and later, we've moved those threads into a single process. So you now have a single reclaim gem with one or more threads that reclaim in parallel. And by doing it in the same process, the same memory space, there's some synergies in there we get with efficiency. So the reclaims actually run faster. We've also added something so that if the database starts getting low on free space, you can suspend the reclaim. A few customers have hit that over the years, where if you're low on space, if you reclaim a lot, it really just makes it worse and you dig the hole deeper. So the system should be smart enough to slow itself down when it runs low on disk space. We have a new list references method. This was a customer request that lists the references to a group of classes. So what we're doing here is you want to know all the references to, say, array in your database. You can do a scan and find that now. So that's brand new. We have a synchronous perform on server now. So now you can do a perform on server, and if you don't want to wait for it, you can kind of start it asynchronously, like this code down below shows. You kick off something with GS host process, you go do something else, and when you're ready to look at the result, you can come back and read the result from standard out. Again, another customer request. This is also a customer feature. We now have a text log file that can be turned on to track things like all logins to GemStone, all logouts of GemStone, database startup time, database stop time, those types of things. So this is really used for security audits. There's some firms, especially public companies, that have very strict requirements about knowing who accessed the data when and what time. And kind of what they did when they were logged in. So this really helps with that. This is currently the data that we log in that file, and this can be changed as you go, but there's a lot of security type stuff in here, like the real Unix user ID, the effective ID, the IP address the guy was on, the client IP address of the PC that did the login, all these different things that security auditors like to look at. So this is really just a text flat file. It's not there unless you turn it on. But it's there when you turn it on. And this is kind of what it looks like, crammed down to a font you probably can't see. We also have new reference path scan methods. And what the reference path scans do is answer the proverbial question, why did my object get GC'd? You know, you go in and you break all the references, so you thought to an object and you run the garbage collection and it's still there. Well, why is that? Well, the way to find that out used to be something called find reference paths, and what that would basically do is start at the leaf object I call L in this diagram and walk backwards and show you a path how the object was reachable from the root set. And that was all well and good, but the problem was it only found one path at a time, and sometimes you missed more than one reference. So you'd find the one path, you'd break that reference, run the GC again, did it go away? No, okay, I got to do this again, and it was quite an iterative or irritating process, depending on how you pronounce that. So what we did in 3.2, again, customer request, is we said, you know, can I just find all the references in one scan? Can I just start at that leaf object and show me every possible way I can get to this guy from the root set? And that took some doing, but we managed to get that working. So now you can run a reference path scan at L, and it'll return you an array of arrays, which is all these object paths to get from R to L, which gets really interesting if the paths cross and you have back pointers. But this can be quite handy. A lot of customers use this stuff, especially when you have several billion objects to deal with. We've added some more multi-threaded operations. These are a little more obscure, but something called Mark GC candidates, where you nominate a list of objects that are probably garbage, and you ask the system to confirm it, and something with pages with %free, which basically tells you the fragmentation level of your database. These are now multi-threaded. They used to be single-threaded. We've also done some more database and memory optimizations. I told you about that customer that has the 2 terabytes of memory. A lot of our historical code was optimized assuming that most of the data is on disks, not in memory. So there are some things that we could do in the algorithms to be more efficient if we know that most of the data is actually in RAM and not on disk somewhere. So we did that for a few of these operations. There's a gem or VM configuration option, gem repository in memory, you set that to true, and then these algorithms automatically kick in when you run these methods. In version 3 of GemStone, most of these things are multi-threaded anyway, so that assumption doesn't hold anymore, but these were kind of a few of the stragglers. Something else that is a historical artifact is most of the memory units in GemStone were expressed in kilobytes for a long time, going back to the day where you could measure your total RAM in kilobytes, a long time ago. But so instead of now having to multiply that by 1024 times 1024 to figure out how big it is, you can now say MB or GB on the end of the configuration option. So here's an example of that. In this one, you can say pre-grow is 4 GB instead of however many kilobytes that is, some big long number. We've also done something with extent pre-grow. Extent pre-grow is when you tell the database when it starts up to go and reserve the disk space that you might need in future. So basically pre-grow those files to their ultimate size so that you don't get surprised later and run out of memory when you try to grow the file. The problem with the way it used to work is it was kind of an all or nothing thing. You could pre-grow it to, say, 64 gigs, but if you only ever use 4 of those gigs, you have a lot of wasted disk space sitting there that you don't need. So you can now kind of do that incrementally. You can pre-grow to an initial size, but also specify a maximum size, which is not the pre-grow size. Again, handy when you're doing a lot of large databases, so you can pre-grow to, say, 16 gig, but say allow it to grow up to 64 if needed. Also, customer request, some people want to run extents over NFS. Generally not a good idea. There's various NFS bugs out there, but to be fair, NFS has gotten more reliable and better over the years, so we now have an option that allows that if it's enabled, if you go and turn it on. Persistent shared counters. This has been in the product for a few years, and it's kind of one of the underused things in our view. This basically allows you to increment an integer number non-transactionally and save it with the database. And it's really good for things like UUID generation, unique serial number generation, and so on, because it's not tied to the transaction. You can just increment one of these things, and if you get the result back, you know that has been saved to disk, and you know you didn't commit or abort your transaction. You didn't change your other objects, because it's really not an object. It's really just a piece of shared memory. And some customers said, that's great, but I need a lot more of these things. You only have 128 of them. I could use many more, so we increased the number to a very odd-sounding number, 1536 in 3.2. I'm not sure why it came out that way. But it's now more than 10x bigger than what it was. So we'd like to see customers use this more, because this is what we see as a very handy feature that was missing for a long time. LDAP, we added LDAP to the product in 3.1, and that's been an interesting adventure, keeping up with the open LDAP releases and so on. We build the open LDAP libraries and ship them with the product. But when we did this, we didn't know that much about LDAP, so we sat down with the sysadmin guys at VMware at the time and kind of said, how do you guys do LDAP authentication? And what they said was, well, you start with a common name, like a Unix name like normg, and then you generally do a query of the LDAP database to get a DN, a distinguished name, which is some big long string that has normg somewhere in the name. But that's a string that LDAP understands. And then you take that string and you do your bind or password authentication against that. And we said, oh, great, that sounds okay. So we did that, but then we come to find out that a lot of places require authentication even to do that first lookup. So you can't resolve the big long DN string from norm G unless you have a password that it basically has to be hard-coded, never changes. Which we said, why do you have the password? Because you can't do anything with it. All you can do is do a lookup. Well, you have to have a password. All of that must be authenticated no matter what. So this kind of broke the way we did things a little bit, because our assumption was that that first bind that strictly did a lookup didn't need to be authenticated. You could do what's called an anonymous bind in LDAP, but we found out a lot of places just mandate, no, all binds must be authenticated, even if it's a well-known password. Fine. So we added some support for that in 3.2. I think it was one of the Glass or Faro customers that wanted this. They were using GemStone as kind of a third-party web server kind of thing, and they had a pool of VMs or gems out there, and they were calling out to an external system to authenticate logins for some site. And in order to do that, they had to do the lookup or the bind with a password, and we didn't support that until now. So long story short, you can now, in Smalltalk code, specify we call that a bind DN and a bind password to do the initial lookup to get the distinguished name that you need to do the real password lookup. Anyway, more than you ever wanted to know, but if you use LDAP, we're going that direction because apparently that's the way the world works. This is something that's fairly new, and we actually have this working. We have one of our engineers on kind of his 20% time built gem builder for Android. So you can access GemStone from your Android phone over the internet via SSL. Just kind of cool. I'm not sure why anybody want to do this yet, but it was nice to be able to say that we could do it. There was a lot of version issues with Android. Android is kind of like Linux. It's kind of like version soup. So it works with version A, but not version B. Steph's nodding in agreement. But we got it to work with some version. I don't know if it's the latest version or not. So this is just a little test app he wrote, and you can download this. I'll show you the URL here in a minute. But this is a database login from an Android device to a GemStone running out on a server somewhere. And to be clear, we don't run the VM or anything on Android. Our VM's way too heavy for that. But this is basically a remote client to a VM running on a server where the client's running on Android. So after you get logged in, then he ran this very simple piece of Smalltalk code on the left, system current session names, and you get this output on your phone on the right. So it just kind of shows the connectivity is there. We haven't really gone any farther with this yet, but it's kind of cool, and we want to show it to you and put it out there saying, you know, if you ever wanted to access GemStone from your phone, there might be a way. No word on iOS yet. That's a completely different kettle of fish, but it might be possible. The code for this is out on our FTP server, and the guy that's doing it is named Bill Erickson. It's kind of his project, so he said put his email address up if you got questions or want to drill down on this or try it out. You can contact him directly. It's kind of his fun little project, so he loves to talk to people about it. What else have we done in 3.2? In 3.2, we totally overhauled VSD, which is our visual stat display program, and that's the graphical program for looking at GemStone database statistics as well as user statistics. This is a collection of about 5 open source projects, and 4 of which have been obsolete since about 2000. So it was kind of cobbled together, and it kind of sort of worked, but then it didn't work on Windows 7. If you ran out of Windows, it would just blue screen and nobody knew why. So anyway, I got finally frustrated with this, and I took about 2 months and went and found in the obscure corners of the internet people that were equally frustrated and ported some of these packages forward and actually got them to work with Windows 7 and later. We also have it for Unix, but Windows was by far the biggest problem getting this to work. And eventually got this going. We moved it to 64-bit because sometimes you'd have statistics files that were several gigabytes in size and you run out of memory and it wasn't pretty. So we wanted our customers to be able to load a stats file of any arbitrary size. So we moved the whole thing to 64-bit program. We went and cleaned out some very old, inefficient code for how the files are loaded. We added a session ID column because sometimes you want to sort by session ID when you're looking for things. There can be literally thousands of rows in this window here. Big one was mouse wheel scrolling. The original libraries were written before there was mouse wheels. Well, somebody around 2005 went out and added mouse wheel scrolling to, I forget if it was the TK or the TICS library, one of the packages that's obsolete. So we got that ported in and rebuilt the whole thing on Windows 7 so it doesn't crash anymore. And here it is. So this ships with the product. It's not actually built with the product, so we build this separately and include it in the install tree. So as a result of that, there's sometimes newer versions of this out on the website than there are product, and they're not joined to the version. The idea is any version of VSD can load statistics from any version of GemStone. That's mostly true. Anyway, that's VSD. Just to review our platforms, the object server supported platforms are Linux, Apple, Oracle Solaris, both Spark and x86-64 and AIX. On the clients, we're running on all those plus Windows. We're now supporting 64-bit VisualWorks images on Windows, which is new. And we're also supporting instantiations 8.6 and 8.5.2. So those are our supported clients. So time to look ahead to 3.3, what we started looking at for that. And there's two formats of these slides. The ones with checkboxes are committed and basically pretty much going to happen. You'll see some later that are just kind of O's. Those are more question marks. They may happen. But the stuff that we know that we're going to do or have already done is the faster VM. We're constantly trying to get our VM to run faster. The VM engineer spent about 2 months this spring and summer optimizing the JIT, the native code generator, for branch prediction on Intel, which is, I don't know, it's harder than it sounds, but that still sounds pretty hard to me. It's a lot of messing around in assembler and low-level stuff. But he got 20-25% improvement just out of that, which was really pleasing. We didn't think we'd get that much. We're